You're welcome to today's class, still on physics. Today we have a problem here. It stated that find the density, problem on density and relative density of solids and liquid. It stated that find the density of a glass block whose length is 10 cm, width 8 cm, and thickness 2 cm if the block weighs 40 grams. Now let's see how we'll solve this in our usual way. Solution: divide the board to contain. Now we start by stating the parameters that are given. Say given, we have here the length here to be 10 cm. Now this 10 cm we converted to meters. We have 10 divided by 100 to have 0.1 meter. We have the width to be 8 cm, to also be 8 over 100 to have 0.08 meter. We also have the thickness stroke height. Let's say thickness stroke height to be equals to 2 cm, which is also 2 over 100 to have 0.02 meters. Now we have the mass as given to be 400 gram, which will also be converted to kilogram divided by 1000, that's 0.4 kilogram. If you have gotten up to this, you have gotten like 50% of the solution of the problem. Now let's describe what's happening here. You said it's a glass block. Let's have a schematic, a little drawing representing the glass block. May not really be a perfect drawing, but it's just presentation of it. It should be like this rather, I think. Okay, I think this will be better. Now I have here to be the length, which is the 0.1 meter. We have here, which is also here, to be the width, which is 0.08 meter. Now I have here from here to here to be the height. A lot of people don't know the difference between height and width. 0.02 meter. Now if you have gotten up to this, like I always say, you have gotten like 50% of the solution. What we have, let me just state it. We have that density presented like this is equals to mass over volume. But volume here, volume is equals to, it's a volume V is equals to length times width or breadth times height. Therefore, the volume here will be, the length here is 0.1 times the width 0.08 times the height, which is 0.02. Therefore, we have that density will be equals to the mass over volume, which is equals to, the mass here is 0.4 as given, over product of the volume by 0.1 times 0.08 times 0.02. Now if you do this whole calculation very well, you have density to be, you have 0.4 over 0.01 times 0.08 times 0.02. You have density here to be 22,500 kilogram per meter cube. As simple as this. Thanks for watching, and watch out for other problem solution still on density and still on this same playlist. So stay glued to your gadgets and go nowhere. See you next class. Bye. Hi guys, you're welcome to another class still on density and relative density of solid and liquid. Today we have another problem here, or right now rather, another problem here. It stated that the absolute density of a piece of Abura wood is given as 0.76 gram per cm cube. If it weighs 500 Newton, what will be the value of its volume irrespective of regular shape? It's an OBJ question or problem rather. We have here A to be 657 cm square, B 658 cm, C 658 cm cube, D 657 cm cube, and D 658 cm square. Now let's see what would be or what the right answer would be. Well, solution, like I usually do and advise, write out the parameters that are given. We have here density presented as this real equals to 0.76 gram per cm cube. We also have the weight W to be 5,000 Newton rather. Acceleration due to gravity G to be 10 meter per second square. Now let's see how we solve this problem. We have that density, this is a lot of mass over volume, but from weight equals to mass acceleration due to gravity, we have that mass is equals to weight over acceleration due to gravity. Now the weight here was 5,000 divided by acceleration due to gravity, which is 10. Therefore, the mass here, 5,000 divided by 10, will have 500 kilogram. Now I've gotten mass, but this mass here will be, okay, but mass equals to this 500 multiplied by 1,000 to have it to be 500,000 gram. It is best left in gram. Therefore, for the problem rather, it's best left in gram. Therefore, from density equals to mass over volume, we are to look for volume. We have volume here to be equals to mass over density. Therefore, the mass here becomes 500 or 500 gram as gotten over the density, 500 gram over density 0.76 gram per cm cube. Now gram will cancel gram. 500,000 divided by 0.76, you have the volume to be 658 times 10 raised to power 3 cm cube. Therefore, in the option, I think the right answer is C, 658 cm cube. As simple as that. Thanks for watching and look out for other problem solutions. Stay on this playlist on density and relative density. See you in the next class. Go nowhere. Bye for now. You're welcome back to class. Still on density and relative density. Today, or right now, we have another problem to tackle, another serious one too. We have here that an iron cube of mass 48 gram and density 8 gram per cm cube is suspended so that half of its volume is immersed in oil of density 0.9 gram per cm cube. So we find the tension on the string supporting the suspended cube. I've said it before that I usually want to take some problem that I assume to be difficult to students because of the intricacies involved. Let's solve this one and you will see what the statement I just made, what it's all about. And let's solve this. Solution, as usual, write out the parameters that are given. We have mass here to be 48 gram. We have density instead of iron cube to be 8 gram per cm cube. We also have the density of oil to be 0.9 gram per cm cube. Now, for the solution, we have that density is equals to mass over volume. And let me also break this down. The mass here is 48 divided by 1000. You have mass to be 0.048 kilogram. And 0.048 kilogram. And the density here, density of iron now is 8 times 1000, which is equals to 8000 kilogram. Now, since we are looking for volume, we then have volume to be equals to mass over density. Therefore, volume here, the mass here is 0.048 over the density to be 8000. Therefore, volume here is, if you divide 0.048 over 8000, you have the volume here to be 6 times 10 raised to the power minus 6 meter cube. Therefore, the volume of oil displaced will be equals to 1 over 2 times 6 times 10 raised to the power minus 6 meter cube for volume oil is equals to 1 over 2 times 6 times 10 raised to the power minus 6 will be 3 times 10 raised to the power minus 6 meter cube. Now, let me also say, therefore, the upthrust is equals to weight of oil displaced. Therefore, you have a mass of oil equals to density of oil multiplied by volume of oil. Now, the mass of oil here, right? Volume of oil. The mass of oil here, has given the density oil equals to 0.9 times 1000. density of oil is equals to 900. So the mass of oil will be equal to 900 kilogram. Therefore, we have your mass of oil here to be 900 kilogram equals to density of oil times volume of oil rather, mass of oil, times 3 times 10 or minus 6 is equal to 27 times 10, 27 times 10 to the power minus 4 kilogram. That's mass of oil. Therefore, weight of oil will be equals to 27 times 10 to the minus 4 times 10 to then be 0.027 Newton. That's weight of oil. Then we have also tension is equals to the weight minus the upthrust U. But weight of oil to 48 over 1000 times 10. We have the weight of oil here to be 0.48. Therefore, tension now will be the weight of oil, which is 0.48 minus the upthrust, which is 0.027. Therefore, the tension here will be equal to 0.453 Newton. As simple as this. 0.45 Newton. Thanks for watching, and watch out for other problem solution still on density and upthrust. Go nowhere. See you in the next class. Bye for now. Hi guys, and welcome to class still on density and relative density of solid and liquids. Today, right now, I have another problem to solve. It states that an object B weighs 80 grams in air and 60 grams when totally immersed in water, and 64 grams when immersed in oil. What is the density and relative density of oil? These are the kind of questions you see sometimes in some from textbooks, expected assignment to students. So let's see how this goes, how to solve it. Solution, as usual, we start by stating that water has, let me present it with the chemical formula of water. Water has a constant density of 1000 kilogram per meter cube, meter cube, or 1 gram per cm cube. We have relative density of oil. Relative density of oil. Relative density of oil, or let me just put it this way. Relative density of oil is equals to weight of oil displaced over weight of equal volume of water. Now, let's see what we're given here. We have that the weight of air is 80 grams, which is equals to 80 times 10, which will be 800. Will be 800 divided by 1000, which will finally be 0.8 Newton. We also have the weight of water to be 60 grams, which is equals to 60 times 10 is equals to 600 divided by 1000. We have 0.6 Newton. We also have weight of oil is equals to 64 grams, which is 64 times 10, which is 640 divided by 1000. We have 0.64 Newton. Now, that is changing it from weight multiplied by 10 and divided by 1000. Now, I have the relative density. Relative density equals to upthrust in oil over upthrust in water. But upthrust in water is equals to, let me say, upthrust in water is equals to weight. Let me represent weight by W. Okay, let's say weight in air minus weight in oil. Now upthrust in water is equals to weight in air minus, also say upthrust in water is also equals to weight in air minus weight in water. Therefore, we have upthrust in oil to be equals to 0.8 minus 0.64. You will have 0.16 Newton. Upthrust in water, you have 0.8 minus 0.6. You have 0.2 Newton. Therefore, relative density represented as RD is equals to 0.16 over 0.2. We have relative density here, 0.16 over 0.2. Relative density to be 0.1 over 0.2, you have 0.8. Therefore, relative density here will now be 0.16. Sorry, density here will now be density in oil over density in water. Now, what is relative density here to be 0.8 over density in oil of density in oil over density in water is 1000. Therefore, density in oil will be equals to 0.8 multiplied by 1000. Therefore, density in oil 0.8 multiplied by 1000 will have 800 kilogram per meter cube, which is also equals to 0.8 gram per cm cube. As simple as this. What seemed to be a very complex unending problem has now become simplified, and this is the simple answer. Thanks for watching, and watch out for the next problem solution. Stay on this playlist. See you in next class. Bye for now. Welcome to class. Still on problems on density and relative density. Without much ado, let's dive right into the problem. We have here a solid weighs 4.8 gram in air, 2.8 gram in water, and 3.2 gram in kerosene. Question is, the ratio of density of the solid to that of kerosene is what? We have is an obedient question, multiple choice. You have A 12, B 3, C 2, D 3 over 2, and E 5 over 4. Let's see what the problem would be. Sorry, what the solution will be rather. Our solution here, we have as usual given, let me just write it here. We have given, we have weight of solid in air presented as WA is equals to 4.8 gram. Also weight of solid in kerosene presented as WK equals to 3.2 gram. Also have weight of solid in water is 2.8 gram. Now we have relative density of kerosene. Density of kerosene is equals to relative density of kero is equals to the weight of solid in air minus weight in kerosene divided by weight in air minus weight in water. This is equals to weight in air have 4.8 minus weight in kerosene 3.2 divided by weight in air is 4.8 minus weight in water 2.8. 4.2 minus 3, 4.8 minus 3.2, you have 1.6 over 4.8 minus 2.8, you have 2. Therefore, relative density, this is equals to 0.8. Therefore, relative density in kerosene is 0.8. Now, density of kerosene, will be relative density of kerosene multiplied by the density of water. Now, relative density of kerosene is given as 0.8 multiplied by the density of water, which is 1. Water has the density of 1, and therefore we have that the density will now be 0.8 times 1. We have 0.8 gram per cm cube. That's the density of kerosene. Now I also have that the relative density of solid we will now have weight of solid in air over weight of solid in air minus weight in water. Weight in air here becomes 4.8 over weight in air 4.8 minus weight in water 2.8 rather. This will now be 4.8 minus 2.8 will be 2 divided by 2. Therefore, the relative density of solid will be 4.2 over 4.8 over 2. We have 2.4. Therefore, density relative density multiplied by density of water. We now have relative density of solid is 2.4 multiplied by density of water, which is 1. Therefore, density of solid here will be equals to, now be equals to 2.4 multiplied by 1 will be 2.4 gram per cm cube. Therefore, the ratio of a solid, relative density of solid to that of kerosene will now be 2.4 over 0.8. Therefore, the ratio is equals to 2.4 over 0.8 equals to 3. As simple as this, meaning that B is the right answer. Thank you guys for watching, and watch out for other problem solution in physics. It could be any problem. So stay tuned. See you in next class. Bye.